Start ko na.
Inventory.
Nag-record na siya. Start na tayo. Good day and good afternoon, everyone. This is the reporter of Group 11, Lean Management. Before we start our discussion for today, let's go first to our first activity titled Jumbled Letter, where each letter that can be formed with a suitable word is related to our topic this afternoon. So, what's our waiting for? So, let's start. Activity, jumbled letters. The directions. Arrange the following set of the letters to form a coherent word. First jumbled letter.
Lean operations.
Okay, thank you. Next, Lady Lynn.
Inventory.
Inventory storage. Okay, thank you. Next,
Product design.
okay, thank you. Product design. Fourth is
Lean services.
okay, thank you. Next, is
Process
process design.
design.
Okay. Next is
Leadership.
leadership. Next, balance system. Next is overproduction. Next is quality
Quality improvement.
improvement. And next, lower cost. Next is
Waste.
weights.
Waste.
Next is weights. Next
Modular
is
design.
modular design. And last one for our jumbled letters is Kaizen philosophy. To start our discussion for today, I will call on Lady Lynn Mahagway to tackle her assigned topic.
First is lean operation, a flexible system of operation that uses considerably less resources than a traditional system. Lean operation is a business strategy driven by the principle of doing more with less. It is a minimalist approach to running a business and improving a day-to-day operation. So, lean operation, it is the key strategy to improving internal functions, creating a productive and engaged workforce, and increasing profits. As companies face increasing competition at home and abroad, finding faster, less expensive ways to operate is necessary to remain relevant and stay in business. The concept of lean operation is a method companies to have been using for almost a century. Next. Lean operation, most manufacturers use an organizational system called Material Requirements Planning or MRP. MRP is a software that allows for planning, scheduling, and overall control on materials used in manufacturing process. Other use an enterprise resource planning ERP, a system Instead, in addition to meeting material requirements, ERP system integrate organizational needs such as accounting, marketing, human resources, and supply chain management. When we look to ERP and MRPs and which type of software is better for manufacturing companies, there are many factors to consider. In this lesson, we explore the top differences between MRP versus ERP. Then we'll take a look at how to access which system your organization requires at this system. There are a lean operations example in every industry. Example is in Amazon. In one company that exemplifies this approach with an commitment to the customer that defines their internal operations strategy. After 25 years, they still follow their original mission. We aim to be Earth's most customer-centric company. Next. There are some ways to achieve the man, lean operation, greater productivity, lower cost, shorter cycle time, and high quality. Next. Lean operations. Lean operation began as lean manufacturing, also known as GIT, just in time in the midst of 19s. Development by Taichi Ono and Shigeo Ono of Toyota. Focus was eliminating all waste from every aspect of the process. Waste is viewed as anything that is interfered with or did not add value to the process of producing automobile. Through the continuous improvement strategy that is foundation of lean operation, innovating new solution to the things makes easier, faster, better, and most cost effective. Their goal is to get products to customers and at an unrevealed pace requires every step in the supply chain to be efficient as possible. Putting lean operation principles into practice begins with an in-depth analysis of your organization's processes and finding alternative, more efficient ways to achieve your business goals. It is also includes optimizing the tangible elements of a business such as workforce and physical environment to improve overall output performance. This lean system has three basic elements. These are driven, focus, focus in waste reduction, and last is has tree culture dedicated to excellence and continuous improvement. First is demand driven. What is demand driven? It is sensing change in customer demand then adapting planning and production while putting from suppliers. From example, an office supply chain store knowing when the client will run out of paper will become a necessary function that customers will expect, forecasting that they will need when they will need it. That's the demand driven. And the next is focus in waste reduction. Work on eliminating waste from the manufacturing process. Um, what is waste? Waste is it can take many forms, but the underlying idea is to eliminate anything and everything that does not add value from the perspective of your customer. And last basic element is has a culture dedicated to excellence and continuous improvement. This is one where an organization looks to improve every aspect of its performance every day at every. Next. Ultimate goal of lean system is balance system. One that achieves a smooth rapid flows of materials through the system to match supply to customer demand. So kailangan yung ginagawa na process na product is or supply is balance lang siya sa customer demand. A well-balanced lean system focuses in maximizing throughput or take time-paced manufacturing to eliminate bottlenecks and in progress or WIP build-up. So, the ultimate goal of creating a lean environment is to cut costs and eliminate waste energy, resources, and time. This is usually achieved through building deliberate workforce, structure, an optimized facility, and refined processes. Lean operation management is often supported by digital transformation that streamline communication and automate internal tasks. So minsan ang mas napapadali sa process ng isang production is mga digital transformations. Next. Goals and building blocks of lean system. Supporting goal is the degree to which lean ultimate goal is achieved depends upon how well its supporting goals are achieved. One is eliminate disruptions, two is make the system flexible, and three is eliminate waste, especially excess inventory. Next. So waste, I discussed earlier what is waste. So represent unproductive resources. There has 7 resources of waste in lean systems. Inventory, overproduction, waiting time, unnecessary transporting, processing waste, inefficient work methods, and product defects. So first is inventory. Waste refers to the waste produced by the process. This includes the waste of capital tied up in inventory, the waste of transporting the inventory, the containers used to hold inventory, and the lighting of the storage space. And next is overproduction. The most serious of the waste, overproduction can cause all types of waste and results in excess inventory. Kapag ng overproduction, halos lahat ng waste is nadadamay kasi like inventory sa waste in time, sa storage, sa excess capital tied up, and useless inventory. So depending of course on the production is in question, overproduction can have very serious environmental effects. More raw materials than necessary are consumed, the product may spoil or become obsolete, which requires that it to be closed. If the product involves hazardous materials, more hazardous materials than necessary are wasted, resulting in extra emissions, extra costs and waste disposal, possible worker exposure, and potential environment problems resulting from the waste itself. And next is waiting time. Waiting refers to waste time because of a slow or halted production in one step of the product chain where the previous step is completed. To take a classic example, for example, is the product line. If one task along the chain takes longer than another, then any time the employee in charge of the next task spends waiting is wasted. The task that takes more time must be made more efficient. Other employees must be hired to help, or the workflow must be better coordinated or scheduled in order to make up for this waste time. And fourth, and the fourth is unnecessary transporting. We all know that transport is moving materials from one position to another. So the transport itself adds no value to the product, so minimizing this cost is essential. This means having one plant closer to another in the production chain or minimizing the cost of transportation using efficient methods. Resourcing and time are used in handling material, employing staff to operate operation transportation. Training implement safety precautions and using extra space. Transport can also cause the waste of waiting, as one part of production chain must wait from the material to arrive. And fifth is processing waste. Over processing refers to any component of the process of manufacture that is unnecessary, painting an area that will never seen or adding features that will not used are examples of overprocessing. Essentially, it refers to adding more value than the customer requires. Six is the pro- inefficient work methods, and the last is product defects. Defective products must be replaced. They require paperwork and human labor to process it. They might potentially lose customers. The resources put into the defective product are wasted because the product is not used. Moreover, a defective product implies waste at other levels that may have led to the defect to begin with. Making a more efficient production system reduces defects and increases the resources needed to address them in the first place. Next. And the Kaizen philosophy for attacking waste is based upon these ideas. So first, what is Kaizen? Kaizen or rapid improvement processes often is considered to be the building blocks of all lean product development. Kaizen focuses on eliminating waste, improving productivity, and achieving sustained improvement in targeted activities and processes of an organization. Lean production is founded on the idea of Kaizen, or continual improvement. Philosophy implies that small incremental changes routinely applied and sustained over a long period result in significant improvement. Kaizen strategy aims to involve workers from multiple functions and levels in organization and working together to address problems of improvement. Now, for attacking waste is based upon these ideas. First is the energy, and to eliminate waste, it is necessary to get the hands dirty. Next is improvement should begin gradually and continuously. The goal is not big improvements done intermittently. The third is everyone should be involved. Next. Next. Next slide. Um, 4. Number 4. Number 4 is Kaizen is built on a cheap strategy, and it does not require spending great sums on technology or consultants. It can be applied everywhere. It is supported by a visual system. Next is it focuses attention where value is created, and it is process oriented. 9 is it is stresses that the main effort for improvement should come from new thinking and new work style. And the last is the essence of organizational learning is to learn what while doing. Next. Um, Lean building blocks, the product design, process design, personal organizational elements, and manufacturing planning and control. Next. First is product design. Product design has four elements of product design important in this lean system. First is first is standard parts. Standard part is any part that can be reused or standardized across an assembly or multiple assemblies. Standard past Parts include fasteners, brackets, cylinders, or even entire assemblies of parts. Broadening the use of standard parts and their application will skyrocket design speed and efficiency for engineers. And the next and second is modular design. A modular design is an approach for product designing which is used to produce a complete product by integrating or combining smaller parts that are independent of each other. With a modular design approach, a complex product, for example, a car, it can be broken down or divided into smaller and simpler components that are independently designed and manufactured. Each of these components is then integrated or assembled to the final product. Modular design is commonly used in various consumer products like cars, smartphones, computers, and televisions. Other modular designs examples include engineering, software product design, and even large websites, with each web page is individual component. A famous example of modularity is Lego. These plastic toys contains elements that can be easily be assembled and reused to develop different finished products. 3 is highly capable system with quality built with. And the last fourth is concurrent engineering. Concurrent engineering is the process of using technology to automatically con- connect connect and communicate product data across globally distributed engineering teams using one or more design tools. An example of concurrent engineering in the automotive industry, organization across industries use PLM for various applications of concurrent engineering. For example, Volvo uses PLM software as the backbone for an industrialized digital thread that improves cross-system efficiency and accelerates time to rocket. And next, the process designs. Process design has 8 aspects of process design that are important for lean systems. First is small lot sizes, setup time reduction, manufacturing cells, quality improvement, production flexibility, a balanced system, little inventory storage, and fail-safe methods. And this will be discussed by Christian Christian Rama.
Naririnig niyo ako?
Oo.
Process this. And first is the small lot sizes. In the Lean philosophy, small lot sizes is the ideal lot size is 1. In Lean philosophy, the ideal lot size is often considered to be 1 in order to achieve the principles of just-in-time or JIT and eliminate waste. The concept of lot size refers to the quantity of products or materials produced or processed in single batch. By aiming for a lot size of 1, lean organization strive to reduce inventory levels, minimize lead times, and enhance flexibility in meeting customer demands. However, it is important to note that achieving a lot size of 1 may not be always feasible or practical in our industries or product processes. There may be a certain constraints such as setup times, equipment limitations, or economies of scale that need to be considered. In such cases, lean organizations strive to minimize the lot size as much as possible while still maintaining the efficiency and meeting the customer's requirement. Some of the key benefit of small lot sizes is first is reduce in process inventory. Well, reduce inventory in reduce in process inventory, small lot sizes helps minimize the amount of work in progress inventory at any given time. This reduces the risk of obsolescence or wastage of raw materials and components. It also allows for better control over inventory levels and ensure that production is aligned with customer demand. Next benefit of small lot size is lower carrying costs. By keeping lot sizes small, the amount of inventory being held at any point is reduced. This leads to lower carrying costs associated with short storage, handling, insurance, and potential obsolescence. It is frees up working capital that can be invested in other areas of the business. Third is less storage space is necessary. Small lot sizes requires less physical space for storage. This can lead to a significant cost saving, especially in industries where the storage space is limited or expensive, such as in urban areas. Next is the inspection and rework costs are less when problem with quality do occur. With small lot sizes, it's easier to identify and address the quality issues early in the production process. If a problem is detected, only a small quantity of products needs to be inspected and reworked, reducing the overall cost and effort associated with quality control. Next is the permits greater flexibility in scheduling. Small lot sizes enable more flexibility in production scheduling. It becomes easier to accommodate the changes in customers' orders, introduce new product variants, or design and response to market demand fluctuations. This agility can improve customer satisfaction and help business stays competitive. Next is the less inventory to work up before implementing product improvements. Its small lot sizes enable more flexibility in production scheduling. It becomes easier to existing inventory that needs to be sold or used up before implementing product improvement or introducing new features. This allows for faster implementation of changes, lending to quicker product iterations and a faster response to market needs. And last is the increase ease of balancing operation. It is smaller lot sizes make it easier to balance and optimize the production operation by reducing the quantity of items produced in each batch. It becomes more manageable to achieve a smooth flow of work, minimize the bottlenecks, and maintain a consistent output rate. Overall, small lot sizes offer several advantages that contribute to improve efficiency, cost savings, quality control, and responsiveness in manufacturing or production process. Example of small lot sizes is, first, in automotive manufacturing. Instead of producing cars in large batches, some automotive manufacturers have shifted toward small lot sizes. For example, Toyota. Toyota adopted a production system known as single minute exchange of dies, or what they call them is SMED, which allows them to quickly change over production lines and produce different models and smaller lots based on customer needs, customer orders. Other example is the food production. Many food manufacturer adopt small lot sizes to maintain product freshness, to reduce weights, and meet the demand for variety. By producing food items in smaller batches, they can store and recover back to seasonal or regional preferences. Next po, set up reduction. Set up reduction is the one of the aspect of process design that are important to lean system. Small lot sizes produce mixes require frequent setups. Ang ibig sabihin nito, small lot sizes and changing product mixes often necessitate frequent setups in manufacturing processes. Small lot sizes and changing product mixes often necessitate frequent setups in manufacturing process. Each time a new product is introduced or different variant, the equipment and machinery need to be reconfigured to accommodate the specific requirements. However, setups can be time-consuming and costly, which can pose challenges for efficient production. Setup time reduction, unless these are quick and relatively inexpensive, they can be prohibited. Meaning, reducing setup time is crucial to mitigate the negative impact of frequent changeover by minimizing the time required to switch between different products or variants. Manufacturers can improve productivity, increase throughput, and respond more effectively to customer demands. Quick and relatively inexpensive setups are desirable to prevent them from becoming a hindrance to overall production efficiency. Setup time reduction requires deliberate improvement efforts, or what they call them is the single minute exchange of die, or SMED. To achieve the setup time reduction, deliberate improvement efforts are necessary. One approach commonly employed is the single minute exchange of die. It is a systematic methodology developed by Shigeo Shingu, a Japanese industrial engineer. SMED focuses on streamlining changeover processes to enable fast and efficient equipment setup. It involves the categorizing setup tasks as either internal or external and finding ways to convert as many internal tasks as possible into external tasks, thereby reducing the time required. Setup time reduction, a system for reducing changeover time. Group technology may be used to reduce setup time by capitalizing on similarities in recurring operations. Homer, pabalik nga. Hindi pa ako tapos. Homer number 2. Another technique that can aid in reducing setup time is the group technology, or GT. GT involves classifying similar products or processes into groups based on their characteristic or operations. By identifying recurring operations that are common across multiple products, manufacturers can develop standardized setups that are applicable to multiple products within the same group. This approach minimizes the need for extensive reconfiguration and allows for more efficient changeover. To summary the setup time reduction, the combination of deliberate improvement efforts such as SMED or single minute exchange of die and the application of group technology can help reduce setup in manufacturing process. By streamlining changeover and capitalizing on similarities in recurring operations, manufacturers can enhance productivity, adaptability, even in the face of small lot sizes and changing product mixes. Example for setup time reduction. In modular design, designing equipment and process with modular components allows for faster changeover. Instead of changing the entire setup, modular system enable the replacement or reconfiguration of specific modules or components, reducing the downtime. Another example of setup time reduction is the visual aids or and color coding. Using visual aids, such as color-coded labels or diagrams, helps operators quickly identify and locate the required components or settings. Clear visual clues eliminate the confusion and minimize time needed to set up the process correctly. Next, manufacturing cells. One of the characteristics of lean production system is the multiple manufacturing cells. This approach offers the several benefits, including the first is the reduced changeover times. Reduced changeover time by organizing production processes into multiple cells, each dedicated to specific tasks or products. Changeover times between different products or processes can be minimized. This allows for faster and more efficient transition between different production runs, reducing downtime and increasing overall productivity. Next benefit is the high equipment utilization, meaning manufacturing cells enable efficient utilization of equipment. Each cell is designed to be handled specific tasks or processes, ensuring that equipment is used optimally. By eliminating the unnecessary movement or transportation of materials and components between distant workstations, the manufacturing cells help minimize idle time and maximize equipment utilization. Number three benefits is the ease of cross-training workers, meaning with multiple manufacturing cells, workers can be trained to perform various tasks within their respective cells. This cross-training enables greater flexibility in workforce development. If there are fluctuations in demand or changes in productions requirements, worker can be easily reassigned to different cells, ensuring a smooth workflow, and avoiding bottlenecks. This flexibility Worker assignment also enhances the job satisfactions and provides opportunities for skill development and and career growth. To summary, the manufacturing cell, the use of multiple manufacturing cells in lean production system contributes to reduced changeover time, high equipment utilization, and ease of cross-training worker. This benefit results in increased productivity, improved efficiency, and better responsiveness to changing customer demands. Examples of manufacturing cells. Example for manufacturing cells. First is the textile production cell. In textile manufacturing cell can be used to produce a specific textile product. For instance, a cell may include machine for cutting fabric, sewing garments, adding buttons or zippers, and performing quality check. The cell can be organized based on the type of fabric or the specific product being manufactured. Another example of manufacturing cells is the in food, in food processing cell. In food industry, a manufacturing cell can be designed for specific food processing operation. For example, a cell may include a station for washing, peeling, slicing, and packaging fruits and vegetables. The cell will be arranged to optimize the flow of ingredients and minimize the contamination risk. Next po, quality improvement. Quality defects during the process can disrupt operations. Automation or JIDOKA. JIDOKA is automation detection of defects during production. Quality defects during the manufacturing process can indeed disrupt the smooth flow of work and have a negative impact on product quality. Automation, or also known as JIDOKA, is a principle in lean manufacturing that aims to prevent defects and stop production where a defect occurs. It involves the automatic detection of defects during production and the implementation of two mechanisms to address them. The two mechanisms are employed is first is one for detecting defects when they occur, meaning the first mechanism is focused on detecting defect as soon as they occur. This can be achieved through various means such as using sensor, visual inspection, or automated testing equipment. The goal is to identify any deviations from the expected quality standard in real time. Another mechanism are employed is another for stopping production to correct the cause of the defects, meaning the second mechanism involves stopping the production process immediately after a defect is detected. This allows for the correction of underlying cause of the defect before production resume. By addressing the root cause, the aim is to prevent the recurrence of the same defect and ensure that subsequent products meet the desired quality criteria. In general, by employing these two mechanisms, automation helps to build quality into the manufacturing process itself. It reduces on manual inspections and relies on automated system to monitor and detect defects consistently. This approach improves overall productivity, reduces waste, and ensures that only products of the highest quality are delivered to customers. Implementing automation requires a combination of advanced technology, robust quality control system, and commitment to continuous improvement. It enables manufacturers to identify and resolve quality issues promptly, leading to increased efficiency customer satisfaction, and ultimately improve business performance. The example of quality improvement. First is the continuous improvement, or we call them the Kaizen. It is encouraging a culture of continuous improvement, promotes ongoing enhancement in process design. It involves regularly reviewing and evaluating processes, seeking input from employees, implementing small incremental changes to improve efficiency and quality. Another example of quality improvement is the just-in-time or GIT. GIT is a key principle of lean manufacturing, aiming to produce and deliver product in the right quantity at the right time, in the right place, by reducing inventory and lead times. It minimizes waste and allows for better responsiveness to customers' demand. And next po, work flexibility. The guidelines for increasing flexibility. First guidelines is the reduced downtime due to the changeover by reducing changeover time. Meaning, implement efficient changeover processes and techniques to minimize the time required to switch between product or setups. This will help reduce downtime and enable fast transition, allowing for increased production flexibility. Next is use preventive maintenance on key equipment to reduce breakdowns and downtime. Meaning, regularly maintain and service key equipment to prevent breakdowns and unplanned downtime. A proactive approach to maintenance ensures that equipment remains in optimal condition, reducing the chances of unexpected disruptions and improving the overall operational flexibility. Another guideline is the cross-train workers so they can help when bottlenecks occur or other workers are absent. Meaning, train employees in multiple tasks or areas to create a flexible workforce. By cross-training your workers, you enable them to fill in for the absent employees or help out during peak demand period or bottleneck. This flexibility in staffing enhances the operational resiliency and agility. Another guideline is to use many small units of capacity. Many small cells make it easier to shift capacity temporarily and to add subtract capacity. Meaning, instead of relying on a few large production units, consider implementing the smaller and more modular units of capacity. This approach provides greater flexibility to shift or adjust production capacity as needed. It becomes easier to scale up or down based on the market demand or changing requirements. Another guidelines is use offline buffers, meaning maintain offline buffers or storage areas for infrequently used materials or product by storing safety stock away from the production area, so you can optimize the use of space and reduce the congestion on the shop floor. This allows for easier access to frequently used items, streamline operations, and enhances the overall flexibility. And last guidelines for increasing flexibility is reserve capacity for important customer, meaning identify key customers or high priority orders and reserve a portion of your production capacity to fulfill the requirements. By doing so, you can ensure that the important of customer receive timely service even during period of high demand or capacity constraints. These strategic allocations of capacity enhances customer satisfaction and loyalty. To summarize the guidelines for increasing flexibility, remember that work flexibility is an ongoing process and continuous improvement is essential. Regularly assess your operation, identify areas for improvement, and adapt your strategies to maintain a high level of operational flexibility. Next is balance system. Takt time. The cycle time needed to match customer demand for final product, sometimes referred to as the heartbeat of lean system. Talk time is often set for a work shift, meaning talk time is a concept used in lean manufacturing and process improvement methodologies to align production rates with customer demands. It represents the time available per unit to match the rate at which customer require the final product. Talk time is often referred to as the heartbeat of lean system. It set the pace price for production. Next slide. To calculate the takt time, you can follow the procedure below. First is to determine the net time available per shift. Meaning, to determine the net time available per shift, it refers to the total time available for production during a single shift, including any breaks, maintenance activities, or non-value added activities. It represents the actual working time. Next procedure is, if there is more than one shift per day, multiply the net time by the number of shifts. Meaning, if your operation runs multiple shifts in a day, multiply the net time available per shift by the number of shifts to get the total net available time for the day. And last procedure is compute the takt time by dividing the net available time by demand. To compute the takt time, divide the net available time by the customer demand or the number of units required within the time period. The customer demand can be based on the number of units needed per shift or per day, depending on your specific situation. The formula for calculating the takt time is net available time divided by 2 customer demand. By using takt time, you can establish a production rate that aligns with customer demand, allowing for a smooth flow of work and avoiding overproduction or underproduction. It helps in identifying and addressing bottlenecks, optimizing resource allocation, and achieving efficient production level in lean system. Next po, inventory storage. Lean systems are designed to minimize inventory storage. Inventor and that designed to minimize the inventory storage. Lean system, also known as lean manufacturing or lean productions, are in that design to minimize the inventory storage. The underlying principle of lean thinking is to eliminate the waste on all forms, including the excess inventory. Lean system aims to streamline processes, improve the efficiency, and reduce costs by focusing on value-added activities and eliminating the non-value-added activities. Inventories are buffers that tend to cover up recurring problems that are never resolved. Inventories, in starting that inventories can sometimes cover up recurring problems that are not resolved. This phenomenon is often referred to as hidden weights, or in lean thinking, when excess inventory is present, it can mask underlying issues such as production, bottlenecks, quality problems, and inefficient processes. Since inventory act as buffer, it can give the illusion that everything is running smoothly while the root cause of problem persists. Inventory storage are buffers that tend to cover up recurring problems that are never resolved, or partly because they are not obvious. Meaning, by minimizing inventory, lean system force organization to address and resolve these underlying issues without the buffer of excess inventory problems become more visible and urgent, leading to their identification and resolutions. This approach promotes a continuous improvement mindset where problems are seen as opportunities for improvement rather than being hidden or ignored. Partly because the presence of inventory makes them seem lesser use. Meaning, additionally, the presence of inventory can indeed make problems seem lesser use. When inventory levels are high, the impact of delay, defects, or inefficiency may not be immediately apparent because the stock is readily available to meet customer demand. However, this can lead to a false sense of security and prevent organization from addressing the root cause of this problem, which can have a long-term negative effects. In summary, malaksan mo pa boses mo. In summary, lean system aims to minimize inventory storage to uncover the address and recurring problems. By eliminating excess inventory, organizations are encouraged to identify and resolve issues that would otherwise be concealed. This approach promotes a culture and continuous improvement and helps organizations achieve higher levels of efficiency and productivity. The example for inventory storage is the full production. In a full production system, production is driven by customer demand rather than pushing product based on forecast. Each process or workstation pulls materials and components from the preceding process only when needed, eliminating the excess inventory and reducing the risk for overproductions. Another example for inventory storage is the supplier integration, meaning collaborating closely with suppliers can help reduce lead times and inventory level by establishing the strong relationship and implementing practices like vendor managed inventory or VMI. Or consignment inventory, suppliers can directly manage and replenish stock based on actual demand, eliminating the need for the organization to store excessive inventory. And last is the fail-safe methods. Next po. Fail-safe methods in a process design are crucial for ensuring the safety and efficiency of a lean system. Pokayoke o fail-saving, meaning it is building safeguards into process to reduce or eliminate the potential for errors during a process. Pokayoke, also known as fail-safing, is a concept derived from the Japanese manufacturing philosophy of lean productions. It involves incorporating safeguards into process or system to prevent or minimize errors and defects. The goal is to design processes in such a way that it becomes impossible to mistake to occur, or if they do occur, they are immediately detected or corrected. The example for Pocoyoke implementation is, first is the electric breakers. Electric breakers is the electrical circuits often incorporate fail-safes to prevent accidents. Electric breakers are designed to automatically trip or shut up the power supply in the event of overload or short circuit. This prevents the damage or to the electrical system and reduce the risk of fire or other hazards. Another example for fail-safe methods is the seatbelt fastener warnings. Seatbelt fastener warnings, many modern vehicles are equipped with Poka-yoke mechanism for seatbelt fastening. These include audible and visible warnings that alert the driver or passenger if the seatbelt is not properly secured. This helps to ensure the safety of the occupants and reduces the likelihood of injuries in the event of an accident. Another example of fail-safe methods is ATM that signal if a card is let in a machine. Automated teller machine or meaning or ATM often incorporate fail-safe mechanism to prevent customer from leaving their cards behind. If a card is not retrieved after a transaction, the ATM may emit an audible beep or display a message to remind the user to take their card. This reduces the chances of cards being forgotten or lost. Another example for fail-safe method is designing parts that can only be assembled in the correct position. In manufacturing processes, components or parts may be designed with specific features or shapes that allow them to fit together correctly in only one orientation arrangement. This prevents incorrect assembly or installation, ensure the product function properly. Example include the asymmetrical connectors or keyways that ensure parts can be only reconnected the correct alignment. This example illustrates how Pocoyoke technique can be applied to various. Next po, five personnel organization elements that important for lean system. First is worker as asset, cross-train workers, continuous improvement, cost accounting, leadership, and project management. Next slide. Next slide. the first personal elements that important for Lean system is workers as asset. In Lean system, workers are considered valuable assets and play a crucial role in the overall success of the system. Here's the further explanation and why well-trained and motivated worker are considered the heart of the Lean system, and how they are given greater authority and higher expectation. Importance of well-trained and motivated workers. Lean system focus on eliminating waste, improving efficiency, and continuous improving process. Well-trained and motivated workers are essential for achieving this goal. Their skills, knowledge, and dedication are vital in identifying, eliminating waste, suggesting process improvements, and implementing changes effectively. They are the ones who carry out the day-to-day tasks and contribute to the success for Lean system. Another explanation is the greater authority to make decision. Lean system often emphasize decentralized decision-making, allowing workers to have greater authority and autonomy. This is because workers are closest to the process and more likely to have valuable insights and ideas for improvement. By empowering workers to make decisions related to their work, Lean system tap into their expertise and encourage a sense of ownership and responsibility. This approach can lead to quicker problem solving, increased efficiency, and better overall outcomes. Another further explanation is higher expectation. With greater authority comes higher expectation. In Lean system, well-trained and motivated workers are expected to actively participate in identifying areas for improvement, suggest innovative ideas, to take the initiative to implement changes. They are encouraged to think critically, analyze the processes, and propose solutions to eliminate waste and enhance efficiency. The expectation is that workers not only perform their assigned tasks, but also continuously seek opportunities to optimize processes and contribute to overall success of our organization. By recognizing the workers as valuable assets, giving them greater authority, and setting higher expectation, Lean systems are create culture that foster employee engagement, promotes continuous learning improvement, and ultimately drives the organization toward increased efficiency and productivity. Pabalik po. Next is next organization element is cross-trained workers. Workers are trained to perform several parts of process and operate a variety of machines. Cross-trained workers refers to the employees who have been trained to perform multiple tasks or work on different machines within a process or production line. Rather than specializing in single tasks, cross-trained workers are equipped with the skills of knowledge to handle various aspects of the job. The concept of cross-training workers offers several advantages. First is the facilitates flexibility, meaning cross-trained worker can easily switch between different tasks or machines as needed. This flexibility allows companies to adapt the changes in production, demands, employee availability, or equipment, breakdowns more efficiently. It reduces the reliance on a specific individual or a specialized workforce, enabling the organization to maintain operation even when certain workers are absent. Next of parts of our process is of cross-trained workers are helps in line balancing. Meaning, in production, line or assembly process, line balancing aims to optimize workflow by distributing tasks evenly among workers. Cross-trained workers can contribute to line balancing by having the ability to perform multiple tasks. If one particular task becomes a bottleneck, cross-trained worker can step to alleviate the bottleneck by temporarily assisting or taking over the task, thus maintaining the flow of production. Example of cross-trained workers is example in manufacturing industry. In, in manufacturing setting, cross-trained workers can operate different types of machinery, perform quality inspections, conduct equipment maintenance, and handle inventory management. They can seamlessly switch between different workstations, ensuring a smooth flow and reducing the bottlenecks. Another example for cross-trained workers is in hospitality industry. Cross-trained worker in the hospitality sector can perform a range of tasks, including front desk operation, concert services, housekeeping duties, food and beverage services, and event coordination. This versatility ensures that the customer needs are met properly and help in optimizing staff utilization based on fluctuating demand. Another example for cross-trained worker is the healthcare industry. In hospital or clinic, cross-trained healthcare professionals such as nurses can be trained to perform various tasks, including the administering medications, conducting patient assessment, assisting in surgeries, providing basic medical treatment. This enables efficient resource allocation, especially during busy period or when specific specialists are not available. Next po, continuous improvement. Workers in lean system have a greater responsibility for quality and they're expected to be involved in problem solving and continuous improvement. Meaning, in lean system, workers are encouraged to take a greater responsibility for quality, are actively involved in problem solving and continuous improvement efforts. To support their involvement in these areas, lean workers often receive training in various techniques and methodologies. Some of the common areas of training for lean workers include the statistical process control. Statistical process control, or SPC, is a method that involves using statistical tools and techniques to monitor and control the quality of processes. It helps identify variations and deviation for desired out standards, allowing workers to take corrective actions. Another common areas of training for lean workers is quality improvement. Meaning, this training focuses on equipping workers with the knowledge and skills to identify and implement improvements in quality across the organization. It may cover topics such as identifying roots, causes of defects, implementing preventive measure, and using quality improvement tool like Pareto charts, fishbone diagram, and Six Sigma methodologies. Another common areas of training for lean workers include are problem solving. Meaning, lean workers are trained in problem-solving technique to effectively address issues and challenges that arise in their work. This can involve structured problem-solving methods like PDCA or Plan, Do, Check, Act, or DMAIIC, or meaning define, measure, analyze, improve, control, as well as tools such as 5 ways, cause and effect diagrams, and value stream mapping. To summary the continuous improvement, by providing training in statistical process control, quality improvement, and problem solving, organization aim to empower their lean workers to actively participate in the continuous improvement process and contribute to the overall success of the lean system. Example for continuous improvement is employee suggestions. Organization that value continuous improvement encourage employees at all levels to contribute ideas for process enhancement. This can be done through suggestion boxes, digital platform, or regular improvement meetings. Employees are empowered to identify issues, propose solutions, and participate in implementing changes and creating a sense of ownership and engagement. Another example for continuous improvement is the value stream mapping of VSM. VSM is a visual representation of the end-to-end process flow, including all the steps, activities, and associated timelines. It helps identify non-value added activities, bottlenecks, and opportunities for improvement. By regularly reviewing, dating the value, organization can continue to identify implement process improvements. So, next po, next po, number 4. Another personal or organization elements that important for the system is the cost accounting. Activity-based costing. Activity-based costing or ABC is a cost accounting method that can be particularly useful in lean system. ABC is a more refined approach for allocating overhead costs to specific jobs or activities based on the respective presentation of activities. It helps provide a more accurate and detailed understanding of the costs associated with different active processes or products, which is essential for lean system that focus on waste reduction and process optimization. Activity-based accounting, activity-based costing is an important tool in cost accounting that complements lean system, enhances cost visibility, improve cost allocation accuracy, facilitates waste identification, support process improvement initiative, and aids in data-driven decision-making. By implementing ABC, organization can better understand their costs, identify areas for improvement, and drive efficiency and effective with lean system. And last is leadership or project management. Leadership and project management play crucial roles in the successful implementation of lean system within an organization. Here's why leadership or project management is important. Una, direction and vision. Effective leadership provides a clear direction and vision for the organization lean initiative. Leader must communicate the purpose and benefits of lean system to the entire workforce, ensuring everyone understands the goals and objective. This clarity helps align the efforts of individuals and team towards common target. Second, the important change management. Implementing lean system often involves significant changes in work processes, roles, and responsibility. Strong leadership is required to guide employees through this change by addressing concern, overcoming resistance, and fostering positive support environment. Effective change management ensure smooth transition and minimize disruption. For more, in summary, leadership and project management are vital elements for successful implementation and sustainability of Lean systems, effectively, and monitor performance and foster a culture of continuous improvement, strong leadership, and effective project management practices enable to continue the report. I will call on Homer Cesar.
Naririnig ako? So,
Oo.
thank you, Mr. Ramat. And here's my part. Manufacturing, planning, and control. 7 elements of manufacturing, planning, and control, MPC, are particularly important for Lean system. The first one is level loading, second, full system, visual system, limited workplace, work in process, or WIP, close vendor relationship, reduce transaction processing, preventive maintenance, and housekeeping. Lean system places a strong emphasis on achieving a stable level daily mix schedule. MPS developed to provide level capacity loading means MPS means master production schedule. It defines as it takes a business plan and other inputs from financial plans, customer demand, engineering, and supplier performance to create comprehensive product manufacturing schedule for independent demand inventory. That is, and its items are finished goods. An example of master production schedule for manufacturing is usually a spreadsheet that contains a production plan consisting list of sales orders from purchase orders and sales forecast and the specific time periods that they will be produced within a 3 to 12 months time horizon. Next is mixed model scheduling. The mixed model scheduling of assembly lines refers to a flow sheet scheduling problem where machines in the same order process a number of jobs batches for the assembly lines. There are 3 issues needed to resolve. What is appropriate product sequence to use? How many times should the sequence be prepared daily? How many units of each model should be produced in each cycle? Communication. Communication moves backward through the system from situation to situation. Each workstation or customer communicates it's needed for more work and preceding workstation, the supplier. Assures that supply equals demand. Ang assures that supply equals demand is work moves just in time for the next operation. The next one is flow of work in coordinate with accumulation of excessive inventories is avoided. The second is pull system. Pull system. Work is pushed to the next station as it is completed. A, a, a pull system is a workstation puts output from the preceding workstation as it is needed. Output of all financial operation is pulled by customer's demand or the master schedule. Pull systems are not appropriate for all operations. Large variation in volume, product mix, and product design will undermine the system. Means a lean pull system aims to create a workflow where work is pulled only if there is a demand for it. The purpose of implementing a pull system is to build product based on actual demand and not on forecast. By doing so, your company can focus on eliminating waste activities in the production process. For example, is just-in-time manufacturing is an excellent example of pull system. The primary concept of GIT is to schedule the process so that materials arrive at the facility precisely when production is scheduled to begin. The production is scheduled for completion exactly when the goods should be shipped to the customer. Next is visual system, Kanban. Card or other device that communicates demand for work or materials for the preceding station. Kanban is the Japanese word meaning signal or visible record. Paperless production control system. Authority to pull or produce comes from a downstream process, ideal number of Kanban cards. Means it is the display of information in the workplace to inform teams, enforce work standard, and highlight or prevent problems. There are many ways to use visual management, and this concept is deeply embedded in lean thinking. The common example of visual management includes labeling supplies and work areas, posting rules and procedures, and using color-coded system to track progress. The next is limited work in process. Benefit of limited work in process. Depending on the kind of work in your team does not the number of people on it. A good starting point is probably somewhere between the number of teams member plus 1 and twice the number of team member. For example, a WIP limit for a team of 5 people is probably somewhere between 6 and 10 tasks. Some of the benefits of having low worker in process WIP. Let's explore each of these benefits in more detail. Lower carrying cost. WIP refers to the partially completed products or tasks in a production process. By reducing WIP, you can minimize the cost associated with holding and managing inventory. This includes expenses such as storage, handling, insurance, and potential obsolescence. Obsolescence, lowering carrying costs can improve overall profitability and cash flows. The next one is increased flexibility. Increased flexibility, having a lower WIP allows for greater flexibility in adapting to changes in customer demand or production requirement. With fewer unfinished tasks or products, it becomes easier to shift production priorities, change product specification, or allocate resources to other areas as needed. This flexibility enables business to respond quickly to the market fluctuation and improve customer satisfaction. The next is aids scheduling. WIP, WIP level or WIP level can impact production scheduling. By reducing WIP, you can achieve more accurate and reliable scheduling. It becomes easier to predict completion times, allocate resources efficiently, and identify political bottlenecks or contains in the production process. It also improves scheduling, can lead to better coordination, reduce lead times, and increase overall productivity. The next is save, saves cost of scrap and rework if there are design changes or product modification. Having as a lower WIP can save costs associated with the scrap and reward. With less work in process, there are fewer particularly completed product or tasks that might become obsolete due to design changes. This help minimize waste, rework emphasis, and the need for additional raw materials. The last one is lower cycle time variability. Lower cycle time variability. WIP can introduce variability in cycle times, which refers to the times it comes to complete a task or produce a product. High level of WIP can lead to longer cycle times and increased variability, making it harder to predict when a particular task or product will be finished. By reducing WIP, you can achieve more consistent and predictable cycle times, allowing for better planning and control over production process. Overall, maintaining lower level of WIP can offer several advantages for business, including cost savings, increased flexibility, improved scheduling, reduced scrap and rework works, rework cost, and lower cycle time variability. However, it's important to strike a balance because extremely lower WIP levels can lead to underutilization of resources or create bottleneck in the production process. Each organization needs to find the optimal WIP level that align with its specific operational requirements and goals. Naririnig po? The next one is close vendor relationship. Lean system typically have close relationship with vendors. They are expected to provide frequently small deliveries of high quality goods. A key feature of many lean systems is the relatively small number of suppliers used. When business have a strong relationship with their vendors, they can have access to the same high quality of materials to maintain the integrity of a product line. For example, a food manufacturer might depend on consistent ingredients to maintain the flavor, consistency, and the price of the products. Next, reduce transaction process. Reduce transaction process is indeed in crucial elements of manufacturing planning and control, MPC, especially in lean system. MPC refers to the set of activities and process involved in managing and controlling the flow of materials, information, and resource within a manufacturing environment. It aims to optimize production efficiency, minimize waste, and improve overall operation performance. Lean systems seek to reduce costs associated with the hidden factory. Lean system aims to reduce costs associated with hidden factory. The hidden factory refers to the activities that are not value added but still consume resources within manufacturing operation. These are activities added to the cost of production without contributing to the final product within the next of the hidden factory. The types of transaction you can mention, transaction you mentioned are significant. The first is logical transaction. This refers to activity related to the movement and management of materials, component, and finished goods within the manufacturing system. Lean system aims to streamline logistical transaction by optimizing inventory management, reducing transportation time, and eliminating unnecessary handling and storage. Second one is balancing transactions. Balancing transactions involves adjusting and aligning production process to ensure smooth flow and synchronization. Lean system focus on minimizing and need for balancing transaction by creating balanced production line, implementing standardized work process, and improving overall system flexibility. The third is quality transactions. It refers to activities associated with inspecting, testing, and ensuring product quality. Lean system aims to reduce quality transaction by implementing robust quality control measures throughout the production process, promoting error-proofing techniques, and focusing on prevention rather than detection of defects. The fourth is change transaction. Change transactions are activities related to frequent changes in production, setups, equipment, and process. Lean system strives to minimize change transaction by implementing standardized work practices, reducing changeover time through techniques like single minute exchange or OPDI or SMED, and optimizing production scheduling to minimize disruption caused by changes. A visual tool to value stream mapping is a visual tool to systematically examine the flow of materials and information. Its purpose is to help identify waste and opportunities for improvement. Data collected is to collect data, we need time, travel, mistakes, insufficient work methods, waiting times, information flows. Number 7, preventive maintenance of housekeeping. Preventive maintenance means to maintain equipment in good operation condition and replacing parts that have a tendency to fail before they actually do fail. Means preventive maintenance refers to the practice of regularly inspecting, servicing, and repairing equipment to keep it on good operation condition. The goal is to identify and address any potential issues before they result in equipment failure or breakdown, minimizing downtime and cost repairs. Here are some key elements of benefits of preventive maintenance. The first one is scheduled inspections. It establishes a regular schedule for inspecting equipment to identify any signs of wear and tear, damage, or potential issues. The second one is lubricant and cleaning. It keeps equipment properly lubricant to reduce friction and wear. Regular cleaning removes dirt, debris, and contaminants that can compromise performance. The third one is component replacement. It identifies parts or components that have a higher likelihood of failure and replace them proactively based on manufacturer recommendation or historical data. The fourth is calibration. Periodically calibrate equipment to ensure accurate measurements and for optical performance. The last one is software updates. For equipment with an embedded software, apply regular updates to address security vulnerabilities, bug fixes, and performance enhancement. Housekeeping. Maintaining a workplace that is clean and free of unnecessary materials. Housekeeping is an essential aspect of maintaining a clean and organized workplace. A clean and clutter-free environment not only promotes productivity but also contributes to the health and safety of employees. Here are some key considerations to effective housekeeping in workplace. There are 8 considerations for effective housekeeping in the workplace. The first one is regular cleaning. We establish a routine cleaning schedule to ensure that all areas of the workplace, including offices, common areas, restroom, and break rooms, are regularly cleaned and sanitized. The second one is clearing clutter. Encourage employees to keep their workstation tidy and free from unnecessary materials. The third is storage and labeling. Proper storage is crucial for housekeeping. Encourage employees to store items in designated areas, labeled containers, and cabinets. The fourth is waste management. Implement an effective waste management system, including properly labeled bins for different types of waste. Give an example like recycling, compost, general waste. Panlima is spills and hazardous materials. It encourages employees to report and promptly clean up any spills or leaks to prevent accidents and maintain a safe working environment. The pang-anim is good ventilation. Adequate ventilation helps maintain air quality and reduces the build-up and dust, allergens, and odors. Ensure that ventilation systems are regularly maintained and cleaned to provide a healthy work environment. Pampito is personal responsibility. It fosters a culture of personal responsibility among employees by encouraging everyone to clean up after themselves and take ownership of maintaining cleanliness in the workplace. This can be reinforced through regular communication, training, and setting good examples. The last one is regular inspections. Conduct regular inspection to identify any housekeeping issues or potential hazards. Address these concerns promptly and maintain a safety and clean workplace. In preventive maintenance and housekeeping, remember that housekeeping should be ongoing effort involving all employees. By promoting a clean and organized work environment, you contribute to the overall well-being, productivity, and safety of your workplace. Transitioning of lean system. So transitioning the lean system, make sure top management is committed and that they know what will be required. Decide which part will need the most effort and convert. Obtain support and cooperation of workers. Begin by trying to reduce setup times while maintaining the current system. Gradually convert operations begins at the end and work backwards. Convert suppliers to GIT, prepare for obstacles. Obstacles of conversion. Management may not be fully committed or willing to devote the necessary resources to conversions. Workers, management may not be cooperative. It can be difficult to change the organizational culture to one consistent with the lean philosophy. Suppliers may resist. Lean services. In service, the focus is often on the time needed to perform the service because the speed of it's the underwinner. In service industries, in service industries, speed and efficiency are often critical factors that can give a business a competitive advantages. Lean services, also known as Lean Six Sigma, it is an approach that focuses on improving operational efficiency and reducing waste in service-based organization. The core principle of Lean is to maximize customer value while minimizing waste. When it comes to service, waste refers to any activity or process that doesn't add value for the customers. This could include waiting times, unnecessary steps, excessive paperwork, and other inefficiencies that slow down the service delivery. Lean benefits can achieve in the following ways. Lean benefits can be achieved through various approaches, and the ones you mentioned are indeed effective ways to achieve those benefits. Let's take a closer look at each of these ways. The first one is eliminate disruptions. By identifying and eliminating disruptions in a process, you can create a smoother workflow with fewer interruptions. This can be achieved by addressing bottlenecks, reducing machines downtime, streamlining communication channels, and implementing preventive maintenance practices. The second one is make system flexible. Creating flexibility within a system allows it to adapt to changes in demand, production variation, or unforeseen circumstances. This can involve cross-training employees to perform multiple tasks using modular or flexible production setups and adopting agile planning and scheduling methods. The next is reduce setup and lead times. Long setup times and lead times can result in delays, increased inventory, and reduced responsiveness. Lean focuses on reducing these times by implementing quick changeover, techniques. Given example is single minute exchange of die SMED, optimizing SMED, optimizing materials flows, improving coordination between process, and implementing full-based production system like just-in-time or GIT manufacturing. The next is eliminate waste. Waste refers to any activity or resource that does not add value to the customer. The methodologies aims to identify and eliminate different types of waste such as overproduction, excess inventory, deflects, waiting time, unnecessary transportation, and inefficient process step. It is typically done through the application of tools like value system mapping, 5S. 5S is the 5S is R. The 5S are sort, set in order, shine, standardize, and sustain. And Kaizen, continuous improvement or continuous improvement. Simply uh, minimize work in process. Excessive WIP leads to increased lead times, decreased flexibility, and higher cost. Lean principles advocate for limiting WIP to reduce inefficiencies and improve overall flow. Techniques such as Kanban system, visual management, and tool systems help to control and optimize the amount of work in progress pala. Sorry. Simply the process. Simply the process. It means simplifying the process involves removing unnecessary steps, complexity, complexity, and non-value added activities. This can be achieved through standardizing work procedures, reorganizing workspace for better flow, and applying visual control to facilitate understanding and adherence to standardized process. By implementing this approach, organization can achieve lean benefits such as improved productivity, reduce cost, increase quality, faster lead times, better customer satisfaction, and enhance employee engagement. GIT 2. A supplier representative works right in the company's plan, making sure that sure there is a appropriate supply on hand. It is often referred to as vendors manage inventory or VMI. That would be all. Thank you.
Homer, okay na?
Tapos na.
Dapat nagpaalam ka na. Magsisave na yun ng misma?
Hindi, save mo yan.
Paano pag titigil to? Patayin ko na.
End mo muna. Yung recording. Stop recording, Ramat.
Hindi ko ma-stop. Hindi ko ma-stop.
Wala, bahala ka.